The first and the foremost factor that a geologist should look for to check whether an area is prone for landslides is the shear strength. So the major thing he should consider is the shear strength of the soil. So we'll go from the basics. From mechanics of structures, shear strength is something, shear force is something that acts parallel to the plane of consideration. We have that normal stress is acting perpendicular to the plane of consideration, while shear force is that which acts parallel to the plane of consideration. So from that only this shear strength is coming up. Now see a block lying on a plane surface. It has normal force acting directly up. And for this is basic mechanics only, which you study in physics in smaller classes. And for the body to start sliding, what should be the horizontal force? So usual basics only. So that horizontal force is given by Fa, which is equal to some coefficient, which is coefficient of friction, given by mu times the normal force, where the normal force is nothing but weight, since the body is in equilibrium in vertical direction. So this is normal mechanics only. There this mu is coefficient of friction, and it is given by tan phi. So in soil mechanics also, this phi means the same, which is that angle phi means the same, where tan phi is the coefficient of friction. Angle of coefficient of friction, I think it's named something. So this delta m given in the figure is will be slightly reduced to that phi, which is the moment when it, that is just if the angle is just below that, the body will be sliding. So it's basics only. So here why I said this, because Coulomb used this particular thing to come into this equation, that is shear strength of soil is proportional to tan phi, that is, or tau is given by sigma tan phi, from nothing but what Fa, from the figure which I have shown before. This Fa we have derived it to be, or we have got it as mu times normal force. So this normal force is nothing but sigma, and mu is tan phi. So Fa, normal force divided by area, so both act, so that will give you sigma. Now Fa divided by area, which is the tangential force divided by area, so it is tau. So dividing the normal forces by area will give you stresses. So we get shear stress is equal to normal stress times coefficient of friction, which is tan phi. So from that only Coulomb got his equation. Now this force of attraction between two soil particles hold the soil strongly against any other sliding forces, so which is called cohesive force. So cohesion adds to this shear strength, so plus C. So this is this so-called Coulomb's equation. Now, so this point will give you the work. The X component will give you the normal stress and the Y component will give you the tangential stress acting on a plane of inclination phi. So from Morse equations you will be getting the equation as I think you are remembering those equations. Sigma n equal to sigma 1 sine square phi plus sigma 2 cos square phi plus tau I mean that here we are not considering tau. Suppose there is no shear stress on the vertical plane or horizontal plane, or else and tau, the tangential stress, sigma 3, sigma 1 minus sigma 3 by 2 sine 2 phi. I think you are getting the equations. Now, if we are combining this with Morse envelope, that is tau is equal to sigma n tan phi plus C. So we can just combine these equations, where sigma n we will be putting in this. And we will be getting equation as some complex equation we will be getting. And one more thing, so what we are getting to, Morse Coulomb's equation gives the failure criteria, that is, if tau is equal to sigma tan phi, then that is the maximum stress it can have. So here itself we can have so many such stresses, so we should be going for the minimum stress satisfying this Coulomb's equation. There will be many stresses that satisfy Coulomb's and Morse equation together, but we need that minimum so as to get the critical stress. So if we are solving for this, when we combine these two equations, we will be getting some complex equation. And if we are solving to get a minimum stress, when we are solving these two equations, we will be getting sigma 1 equal to some sigma 3 in terms of sigma 3 and all. So we require that minimum normal stress that minimum normal stress satisfying both the equations. That is Coulomb's criterion and Moore's criterion. Why we go for minimum? Because that way can take us critical. We can make sure that whatever stress, normal stress acting is below this particular sigma 1. I think you are getting into the point. And when we solve and find, we will be getting sigma 1 equal to sigma 3 tan square (45 plus 5 by 2 plus C tan 45 plus 5 by 2. So this is that particular equation, combination of both. Now this 45 plus 5 by 2 we can take it as alpha also. Now we'll move on to, so I think you got the normal stresses in case of inclined planes, and what is angle of friction phi, and there is another angle called angle of repose, wherein if we are making a particular soil into a heap, that is angle of repose. If we are making a particular soil into a heap, the soil will be sliding down to such an extent that finally it becomes stable to form a heap.